Welcome to Data Preparation and Workflow Management. This is the opening live stream. And like earlier, I asked you to turn on your cam and use the chat as actively as you are. If you have not discovered the course website yet, please do so now. I've put the link to the website in the chat and you see it on the screen as well. To be able to access all the course material. Can you hear me? Because Julie doesn't hear me. Okay, Trang hears me, so that's good. So Julie, the problem is on your side. Maybe someone, yeah, I don't know. You can offer some support to Julie. And I'm recording this, but of course, Julie doesn't hear me, so she won't hear that. So there are a couple of parts. Great, Julie, you're aboard. Hi. So there are a couple of parts that I wanted to do with you this morning. By the way, to those students who haven't met me, my name is Hannes Datta. I'm an associate professor at Tilburg University, and I'm teaching this course. I developed it because I just love the content, and I've tried to lobby for this course for a very long time. And finally, I got the chance to be able to teach it. Just like online data collection and management, another course that you may or not be enrolled in. So the problem that I'm facing in this afternoon is that I have already met many of the students. Actually, I think 95% have already been in my introduction stream this morning. And I spent a large amount of time talking about, who I am, what I do, and, all the fun activities that we have at Tilburg University for marketing analytics students. So I'll skip this part now and defer to the recording of that lecture, which eventually gets posted to Canvas or YouTube. In this respect, I am still looking for teaching assistant support in editing, video editing. So if you have, a good, experience with, editing video and making them look a little flashy, please be in touch. Later on in this lecture, you can scan the QR code to send me a WhatsApp message. And because I'm so much in need of somebody to assist me on that, you can also use email to be in touch with me. More about this later, but please, I need some support and you'll get paid for it, obviously. So, for a couple of hours a week, maybe like a fun thing to do. All right, so I'll skip the getting to know each other. Just, I'm Hannes, and maybe the most important thing you need to remember is don't treat me like a distant professor, but treat me as your coach, somebody, who is interested in your development and in learning about whatever we do in this course and beyond. So I'll skip to the parts about the motivation of this course right now. And I'll have to go to my next slides, which I hope you can see. All right, so I did my PhD in quant marketing, so something with numbers in marketing, right? In the field of marketing, we also have consumer psychologists that would collect data in lab settings, right? So they would send, I don't know, pay students, for example, to come to the lab, like a computer lab, and they have to fill in surveys and they do their research like this. But quant marketing is a little different because mostly we work with data sets that we collect, for instance, from the internet. For those students who are here and haven't been there this morning, online data collection and management is probably what you should take to learn how to extract data from the web, right? But once we have data, and it can come from the web, but it could also be retrieved from the databases of companies, we need to do something with it, right? We need to turn the data, find a good research question. Well, maybe we should have that one before, and turn data into insights, all right? So in my PhD, that's what I did. And I coded a lot and like stitching together data sets, like, taking one data set and another data set and merging them, stitching them together. So for example, I had a data set on how many, I got tracking data from a digital TV company, and I knew exactly which customer zapped to which channel, right? So, and I wanted to analyze like what drives the usage of interactive TV, right? Something that may drive the usage of interactive TV is when the firm sends out promotional messages. Hey, Hannes, we added 3 shows on, that and that digital service, right? But the data set is different, right? That first data set, that's consumer level data. So I have like Hannes, his anonymous customer ID is 1234, and he's up to channel 30, channel 50, channel 60 on a particular day, right? But that promotional data is different. It just says like, you know, we sent a message to Hannes on, let's say, the 1st of December and the 15th of December. So I need to stitch these two data sets together. And that's what we call merging, to analyze, for example, the relationship between sending promotional messages and watching TV, right? You know, you may know this from Netflix. We are probably all on Netflix. So you get these weekly reminders, hey, we added this show and that, right? And Netflix may run a similar study, right? They want to know how effective are their like promotional messages to suggest you content via email, to draw you back to the service, right? So you stitch together different data sources, and those can come from the same company, but they, you know, one could be also like data that you retrieve from the web. You merge that with internal company data, and then you also go to, I don't know, some other publicly available website to download weather data, which may be like important if you analyze TV behavior, right? Because if it rains, I watch a lot of TV. If there's sunshine outside, I'd rather spend time, you know, going for a run or something, right? So it's a little bit of what I did in my PhD, but I messed it up completely. So I created a complete chaos in my file system, and I'll post this link to the chat so you can check it out. This is actually a copy. You can't access any files, by the way, but a direct file and directory copy of my PhD project, all right? Just try to find the final results of my paper. Come on, you have 2 minutes. Which folder do you go? You know, maybe model runs? And you can click on it. Huh. All right, so I estimated a hell lot of models. Maybe I can go to the folder final exclamation mark. But I don't know. Yeah, maybe final. Oh, well, I consider many models final. So which one is really final? Maybe I sort by modification date. Yeah, that may get me to the, whoa, it's not even the results. It's just some code. So it's not actually results because it ends with .r, right? I don't save results in .r files. So maybe that's not it. Maybe I should go to code. Yeah, I don't know. You know, this is such a mess up. I am not able to reproduce what I did in this, you know, with this file system. And, you know, maybe you can assist me to find the final results. I'm not sure. It's chaotic, and I still got published. But, you know, I can't find the code that prepared my data set. I cannot find the code for the econometric model, the regressions, like the analytics stuff that I was doing in this project. And what's so bad about it? Well, today I can't reproduce the results. And sometimes I get email requests like, hey, can you correlate, or can you compute the correlation between A and B? Because I need this for my paper. Can you please help me? Well, I don't even know what is the final data set of my paper. Sorry. Replicability. My peers in the field, and neither you, if you ever saw that shitty code, will be able to understand how I did things. So you can't learn from what I did, which is like super inefficient because, you know, that's what we do at university. We learn from each other. And then even while I was working on this project, you know, when making changes to the data, which trust me, I did 100 times, right? You know, computing advertisement like this, controlling for population size, you know, I had like 100 versions of the same variable just because I was trying out different things. But I had to execute my code over and over again. So, and then I forget about in which order stuff is executed. Let me show you this. So there is this code folder up here. And, you know, these are all the files needed for my project, but I don't have a clue which files to execute and in which order to execute them. It's going to take me, you know, a long time to figure that out. Do I start with selection? Okay, probably I take the last version. Or should I first do the setup or the usage? Or are these independent from each other? I don't even know penalty variable. I don't even know what that is and why I did that. You know, just let's forget about this. This is hopeless. And you need to care about this, because you will soon embark on your data intensive projects, whether for your thesis or in business. And you will change the code that you write to run your projects continuously before your project is final. And after your project is final, you'll keep on revising your code because you still find errors. So you need to automate the process of like your whole project. Sometimes also you want to collaborate, right? So you're getting onboarded to a new team and colleagues need to understand your code to help you, but also just to continue your work when you exit the organization. We need to do things differently than how I did them and how I learned them. Actually, I didn't learn it. I just thought about I was doing the right thing, but I didn't. It's a costly investment in terms of time and effort that you go through, but the efficiency gains that you get from it, they will pay off. So why do I want you to become efficient? And what actually characterizes this efficiency that I want? Right? So what is efficient? You know, imagine you could have your analysis run within 1 hour, although for your thesis, right? You know, load in some data and run a first regression to estimate whether promotional messages on Netflix drive video consumption. Let's just take this as our exemplary thing. Of course, it's not final, right? You want to control for the weather. You want to, you want to do all kinds of things. You want to filter out on particular users. You still need to collect age and gender information. But hey, come on, let's just have this first model. You are up and running in less than an hour, I promise you. This is what I mean by, prototyping the final pipeline, the final product, and later refining and improving. So rather than working forever and I don't know, your thesis deadline is in a week from now, and I still haven't looked at the results, but I will eventually do it. You look at the results in the first day itself, but you refine. This is a different way of thinking, but always think as a minimal product that you can have, you can show to others and get feedback, and then you improve continuously on the project. Prototype the final pipeline, refine later. Also, what's efficient is to reduce setup costs to return to a project. Now, suppose, well, actually, I'll show you that right away. I will have to close this lecture in 1 hour. This is earlier than expected because I have a very important call with co-authors in Australia and in the United States. And it just works out best in time if we have to do it. There's no other time actually to meet with people from Australia and the East Coast in the US at this moment in time. So sorry for that. I have to pass on you. But what this meeting is about is that one of my papers got around further in the review process. So, I write on papers, and that's somewhat how I make my academic career. And I haven't looked at the paper in 3 months because I got expert reviews evaluating my work. And now we're meeting to discuss the comments and start working on this revision. Suppose the project looked like the shitty project I've shown you before, I wouldn't know where to start, right? But today, actually, my projects, they look, and it's not here, it's actually on a different computer, so I can't show you, but, actually I can, because they're on GitHub, something that you'll learn. So here you go. This is how my projects look today. All of the code is documented. I know exactly where I want to go. I think today we're going to talk about the post analysis. I don't need to go in. There's even a recipe book on how to run my stuff, like which files to execute first. No worries, I'll show you in a bit how that exactly works, but exactly know how to get in. The only thing that I need to do in this project to start it up again is typing make in my terminal, and that's it. It will run and process everything from beginning to end. So my setup costs to return to a project are literally zero. This is efficient if you pause working on a project, but it is also good to bring down the setup costs of onboarding other people on your empirical research projects. It reduces mistakes because that's efficient, by the way, reducing mistakes or catching them. Another thing in which you can boost your efficiency is rotating on tasks, right? You're brain dead from coding because you've spent already 5 hours, but your colleague can still run your code and continue. That is something that you should be looking for. Something else that's super useful is, reusing code that you've written. I'll show you in this class how you can write a little package in R and, package your function so that other people can use it. So what I did, for example, is I wrote a little package, and it's rudimentary, but I use a lot of music data in my research, and I built a little package that helps to classify names of music labels, Universal, Sony, BMG, Epic, into whether they belong to a major label or an independent label. It's a niche function. You'll never use this, I promise you. But it's I care about it, and some other people may use this, not you, but maybe some other people, and maybe you invent a function and you can just like wrap it in a package. That's efficient, right? Enabling team members to take over parts of your work is efficient. Receiving feedback from others is efficient. So like on my work, let me show you. So I have another thing. It's called gist. This is not like entire projects, but what this is these are code snippets that I've written. So for example, this is a little tool to install packages automatically in R. This is, this is all specialist stuff, but what sometimes happens is that people comment on this and give me feedback. People I've never met in my life, but, and I don't know where to find this feedback. It must be somewhere else. Somebody forked my stuff. Yeah, I don't know. I don't know where it is, right? But like, if you open this and you want to improve on my code or use this code or just leave me a review on how that worked, you could just do this. So you can receive free feedback on your stuff and then reintegrate that in your project. What's not efficient? I hate waiting. I'm probably the most impatient person you ever meet, at least in this semester, maybe, I don't know, right? Like waiting for results because your algorithm takes a long time, or for estimating, right? So if you automate everything, you could just like go and have a coffee while your computer is at work, or you could run it at night. And every morning that you start up your computer, you look at the new version of the results, depending what all of your team members have done before, you kind of went to bed. Distraction is something that I hate. So the thing is, sometimes it just like takes like, I don't know, a minute to run something, but a minute is enough to get you like go to other places. You open YouTube and you're lost for the day or something like this, right? So you want to reduce this waiting time everywhere to kind of keep your focus and work efficiently. Forgetting how things are done or were done is problematic. Losing data is even more problematic. Using code which isn't documented well, so you don't really know what it produces. Becoming frustrated, feeling lost, that's all of the things that you want to avoid when you work on empirical research projects. By the way, Rachel posted a question to the chat about a public, about a WhatsApp group. So I just want to point out there's a QR code that I'll show you in a bit to get onboarded on a private chat with me on stuff. I haven't organized an app group for you guys, but probably you have already. So I would say just post it to the chat. And if you want to, I'm not going to join, your student group. You can do whatever you want if you want to discuss. So just somebody post the link to the group. So to get Rachel onboarded on this group, but we'll keep that students only. And if you want to invite me, we can discuss in class, but I'll leave that up to you guys first. Okay. But don't feel afraid of like posting stuff here publicly. All right. So what are the objectives of this course? So first of all, let's develop your coding expertise and your coding skills. And I want to show you a little bit about what I'm thinking. For example, you may want to produce good looking documents in what is called R Markdown. So for example, we have a tutorial where I'll show you how to produce documents like this. And you can use this markup language, that's what it's called, to mix text like a report with data. For example, here we're loading in data. And then we're exploring this data by looking at it. And maybe even we are plotting data and we're cleaning data. Let me see. Let me maybe show you another thing that I've done for my reports. Let me see. I'll just go to my project folder for this project where I meet for a revision later. And much of these meetings that I have with my co-authors, I don't know what pops up now. I produce documents. Okay, this doesn't look like clean, but these are automatically generated documents with model results. And I, would just like quickly prep these docs before the meeting, and then my co-authors get access to these docs, and we can look at the most recent results. Let me show you something else. Where is that? 2000 overview. I don't know. Do I have like better looking documents because they look? Yeah, this is, for example, a document. So this is a document I did in Markdown, and it essentially already looks almost like a paper. So you can write papers in this document. You can write your reports in this document. But all of this directly comes from the data. Suppose I use a different way to measure GDP, and trust me, there are many ways to measure GDP. I just like change the operationalization of this variable somewhere in my code, and this document automatically gets updated. So bye, wasted time in prepping these docs. You'll just do it on the fly. Okay, so this is just like one of the example docs that I created, and I'll show you how you can take data and turn them into documents like this. The keyword here is R Markdown. This is a different course. Where is it? I'm lost in browsers. Another thing where coding expertise comes in is in app development. Actually, in this class, I'll show you how you can write little apps that run in your browser. And actually, all of the code, for example, for this app is shared on our website. So, you could just like try it out. So for example, this is a public data set on COVID cases. We haven't updated it in a while. And you can like, this app was written in a way to compare cases between provinces. It's purposeless, actually. It's nothing, nobody's using this, but this is a demo, right? How I turn this into productive use, though, is, and I'll pause my screen real quick because I need to log on to a different computer because I want to show you what I did in this research project. And I need to sign in. Okay, that will take just a second. Give me a second to sign in on my team viewer, and I need to activate properly. Just a second. Team viewer. Where is it? Team viewer. Yep, there we go. And I'll show you my screen real quick in a second. Oop. Trying to log onto the computer. So let me resume the share. There's a whole bunch of stuff going on here, but my project sits here. It's not of so much interest. But I told you it's kind of a clean project, and I'll start up the app now, which I'll just do going to the app launch and just like clicking on run app. And this just runs on my computer, but I can just like publish it to the web. So this is my research app, which I've just written, which I've written in this project. It displays the results of a regression model. Regression is like a way to understand the relationships between variables. So for example, whether high equity brands, this is brand equity, and it's for internal use, right? It's not for the public, but whether brand equity has a relationship with how people react to price promotions. So, price goes up, what happens to sales, right? They go down. But this, for high equity brands, this effect is even longer. I don't know. I don't need to go into the results. But what this app did is it enabled my senior co-authors who are not familiar with R, actually, to still run my models, because they could just like swap variables to understand, how the relationships that we study will change, to kind of understand what goes on in our data. Another thing that you will learn in terms of coding is how to stitch together complex data sets. Really learning it will take years, but these are the first steps, and you can develop. And there are many people in the faculty here in the marketing analytics program that can help you, advance these skills. One of them being George Knox, another one being Lachlan Deer, another one being Max Pachali, another one Shravasti Banerjee. So we got a bunch of coding people that use these kind of things where you can learn. So what are the second set of course objectives? The second thing that I want to do here in this course is to help you collaborate on research projects using GitHub. GitHub is a tool owned by Microsoft, but previously it was independent. Let me just open a private window, see it. So it's actually where the world builds software in essence, right? So you can have private spaces in which you can develop software on your own or in teams and nobody sees it, but you can also develop open source software where everybody can see. And I'm trying to make as much code as I have publicly available. And I'm teaching you this tool. The reason being that, either GitHub or any other kind of GitHub clone, because there are many, GitLab, I think, and I don't know, Bitbucket. There are tons of versions like this, but the essence is the same, right? It's a platform to help you manage the code of your projects. And you can, have a repository, let's say for projects, where you keep the code of your projects, some of which are private. I think this is a private repository, and some of those are public. You do not only have code, but you also have issues that you want to work on, right? It's a platform to communicate with each other. Rather than like having a team meeting and like, what do we want to do? You just post an issue. And when you meet, you go through this issue board and kind of decide on, priorities. And you can assign it a label. For instance, this is a good first issue. Suppose you don't have time to work on this project, fine. But the first thing that you do when, you want to get back to this project, I have an hour now to work. That's at least what I do. You open the issue board and look at the good first issues. And that's what you just work on. You don't need to worry about the entire project. Just like work on this little issue. Leave a comment to other people about it, for instance, to my colleague Max, but you can also just tag it being done. And that's, let's say, how you collaborate with others. Sorry for the slide design. I realize this is not so optimal, right? We also have, for example, an issue page for Tilburg Science Hub, a platform that we massively make use during this course because it was developed as a result from last year's dPrep. And dPrep, in dPrep, I try out new stuff, and when it matures, I'll move it to Tilburg Science Hub, which is a place, to learn working on empirical research projects. It's actually the public and nicer looking version of dPrep, right? What you can do too is you can just like learn, view, run, learn, and extend the work of others. So for example, I have a published paper in the Journal of Marketing and all my code is here. Just go take it, do whatever you want to do with it. Also, I have a public algorithm on clustering playlist data. It not only contains the algorithm, but it also contains the data. So, if you're interested in playlist data, just go and take it. Even this class is actually openly available with all of the source code. So the only thing that you need to do to make a clone version of this is click on fork, and then you have your own version of this course. And you can, I don't know, develop something that you think is better, develop the better version of this course. And you can let me know about it. And when I like the features that you develop, I can just integrate them in my course. This is a new way of working together. And you'll learn about this. And then also I'll teach you how to document your own code, document your data, and use GitHub's powerful feature of having an unlimited version history of anything that you ever did. Wonder how the syllabus looked like, a year ago? I mean, I know this is not interesting, right? But think about your project, a research project, that one little model you estimated a year ago that you want to revive. Well, you can go back in time. So for example, look at how the schedule evolved, but just clicking on history, and you can see all of the changes I've ever made to the course schedule of online data preparation workflow management. Obviously, it's not important, it's not relevant, but for research projects, it is, right? You can go back in time. The good thing is that if you go back in time, if you can do that, you're not afraid of deleting stuff that you don't need anymore. If you look at code, honestly, many people have comments or stuff that they wanted to run, but then it didn't work, but they still keep it inside because maybe I need it later. It leads to the messiness I showed you at the beginning of this course, right? You just keep everything because maybe it's useful, and it creates a chaos between something you need and you don't. If you have an unlimited way of rolling back, you can just like get rid of the stuff and keep always a very clean looking repository, because you can go back anyways if you need to recover something. It's a very, very powerful thing. And then finally, I'll show you how to automate your research pipeline. So for example, automation means the project runs, but just typing a command when you download the project. And I'll show you real quick what I mean as a preview. So on Tilburg Science Hub, we have a little tutorial of how to do text analysis with Twitter data, but it's also here to demonstrate the power of automation. You can do this tutorial on your own pace. I think what I wanted to do is just run it. And the tutorial has videos and does everything for you. The only thing that I'll do is now I'll take a copy of this and I go, I make a new directory, mkdir, make directory. On Windows, it may be different. And I do git clone and I paste this URL. That's what you need Git for. By the way, Git has a user interface, but I don't use it. But you can use it if you like. And now I have a copy of this, of these files. So let me go to it. I think I dumped it in. So that, where am I? Do I have it here, dPrep? No, I think it's dPrep. Here it is. Text mining workflow. It has some source code. It contains an analysis and some data preparation. But other than that, there's nothing here. Well, let's look. I get all the instructions. How do I run it? How to get started? Well, follow our tutorial, blah, 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 and then type make. Okay, let me just do this. And I'm typing make. And I'll show you what happens while I'll do this. I hope it runs. Oh, no targets. ls, I need to go to the directory. So I type make, and now it's downloading the data because there was no data, right? And if you watch closely, it may take a while. I hope the data is still up and running. Not, oh, now I have a data folder and there's some data on Fortnite tweets, whatever, a game my nephew likes to play. Oh, suddenly I have a gen folder. What does that mean? Oh, generated files. These are files that are generated as a result from running source code. Ooh, some weird shit going on here. I don't know. So let me see. Data preparation. Oh, I have some temporary files. Oh, apparently I've unzipped the data. Cool. And some output. Oh, this seems like the final data set that will eventually be analyzed. In the meantime, make is done. By the way, I'm opening the data. You can check it out. Okay, so it has a tweeting ID, when the time, the timestamp when the tweet was done, and the content of the tweet. That's kind of it. Okay, so I got this. And any final results? Well, analysis, output. There's an HTML website. Whew, let's look at it. Boom, here's your final analysis from running this whole thing. Got some summary statistics, some plots, histogram. Well, that's it. It's basically minimal. But what I've just done is I took a project, a mock-up project, and I just typed make and it builds. Well, just imagine the power that you have at your fingertips that you have. Marit, it's going very fast, I know. So you'll learn all this. This is a preview of stuff, all right? So maybe what I want you to remember is that automation does many magical things. Automation allows you to return to a project because you have documented the way things are needing to run, and it allows other people to also run your stuff. So it's a big, big time saver. If you think back about the chaos that I created it because I didn't know about the existence of these tools before. That is why I'm teaching you these tools. If even this is complicated or too fast, let me just remember, let me just give a message of like 3 things, right? If you improve your coding or learn how to code because you're newbies, right? If you improve the way you collaborate, rather than having a to-do list in Word, using GitHub, or rather than using Dropbox, using GitHub. So code, collaborate. And the last thing, automate. If you learn how to automate, these are going to be like 3 pillars that are going to define the way you do work. and it's going to be helpful for you. And you just need to trust me on this, okay? That is actually all of the messages that I have. So sorry, maybe I'm throwing so many examples at you at this stage, all right? Another thing is you can start projects from templates. So I have a couple of links of templates, right? But you know, it's like this app which I have shown to you. It's a template. You just take it, put in your own data set and run it and see what happens. You know, that's also something that's very efficient, and you'll learn that. Marit, are you with me again? I hope. I'm trying my best, but thanks for putting it in the chat. Finally, coding, collaboration, and automation are going to be implemented in a project, data or computation intensive project. What does that mean? You know, big data, loads of number of cases, different kinds of data sets, maybe data which has problems and errors, like social media data. Sometimes, you know, people write in languages that you didn't even know existed, and then you're trying to load the data, but your computer doesn't know how to interpret characters that are non-English. And the velocity, the speed in which data is being generated, that is data intensity. So for example, Twitter, right? So if you monitor tweeting activity, it's real-time data and like stuff comes in. How do you handle that data, right? That is a data intensive project. Or a computation intensive project, which means like a small data set, just a couple of hundreds of observations, but very long computation time, because you know it takes a long time to process this because you're using some advanced analytics algorithms to run on this. And your project is going to feature one of these two things or both. All right. In learning how to code, collaborate, and automate, and implementing this in a project, that's essentially the content of this course. And this course is structured in basically two big blocks. The first block is a skill building phase, 5 weeks. It's starting today. And it always follows the same kind of order. You'll first have a week starter in which I give you like a little motivational pitch on YouTube on what is there that you need to do in a given week. By the way, I haven't recorded it for this week, so consider this your pitch unless I find the time to record another pitch. Then you have self-study material that I expect you to work on independently. Of course, I give support throughout, and I'll show you how. And then there's going to be a live stream for feedback and some immersive activities, something new problem to solve, working together in groups. Okay. If you go to the dPrep website and click on modules, click on week 1, you'll actually see what is the planning for this week. So we've covered the introduction to this course almost, and I've shown you a bunch of examples actually on what you're going to build in this class. And I'm almost about to introduce you to the data sets. All right. And these are the self-study, and then we'll get a second live stream scheduled for the tutorial this week. It's always the same thing. And then in the last 2 weeks, well, actually not, throughout the entire course, this is new this year because I changed the course a little bit, you're going to work on a project and apply all of these skills in a team. You're free to choose who is on your team. And I suggest you to pick a diverse set of people, right? Pick somebody who knows a bit of coding, pick somebody who is familiar with the context that you're going to work on. Yeah, if somebody is in his second semester or her second semester at Tilburg and still joins this course, maybe you want somebody of those people aboard. I don't know. You'll figure it out. Be diverse. That helps. And the project gets more complex as we go, right? In the first week, you just do a bit of data analysis, but no serious work on GitHub. And then in the next week, you're going to learn how to use GitHub, and then you're porting your project to GitHub and so forth and so on. So each iteration of this project gets more and more close to the real thing. But just like I said, you have a pipeline, like a little project, and gradually you improve, because this is also how you work together. You start on something that's small and maybe still buggy, it doesn't work, and you'll improve it on the way. And throughout, you make use of building blocks and code snippets to customize your projects, some of which are posted on this website. Building blocks, right? Cheat sheets, for example, for our software that we're using, some code snippets for regression analysis, some code snippets for app development, some code snippets for automation. But much of the material is also available on Tilburg Science Hub, which is, let's say, the more public version, more complete version for anybody in Tilburg and beyond to use, with loads of building blocks that support you in your research process. You know, want to develop your coding skills? Well, here you are. Maybe a few starters. It's not complete. So if you have suggestions, you can help us make this site even better. How to store and document data, how to analyze data. Maybe you want to run some machine learning algorithm. I don't know much about machine learning. Maybe you want to learn it. Well, here you go. This is your entry gate. Okay. There is a very, very detailed project page. If you click on course team project, where I define the learning goals, and I explicitly tell how the coaching is going to work out. Something that's new this year and I'm trying out is a work plan in which I give you ideas, suggestions on what to work on. It's actually important that in this first week, you already get onboarded. Unlike in online data collection and management, where project work starts in week 2, you actually have to find team members, right? For example, thinking about the research motivation. But everything is here, and I hope it's clear. If it's not, let me know. I expect you to work in teams of 4 to 5 students. Okay, because somebody asked, Robin asked this question in the chat. Any questions so far? You can also draw, more visual version of this course, right? You'll learn a new way of working, code, collaborate, and automate. And you're going to apply this along the research process of exploring data, prepping data for analysis, cleaning out cases that are irrelevant, making variables that you want to study, running the analysis, and actually reporting the results. I didn't call this reporting because I don't want you to end with writing a PDF report. I want you to think, that's an option, obviously, but, you can also write an app. And this is going to be featured in the team project. Like I said, we got a course website. It's open education, so spread the word. So if you find this a useful resource for others, please tell them about the existence of this. The same holds for tilburgsciencehub.com. We only use Canvas like in online data collection and management for posting, announcement, and signing up teams. But all of the content of this course is publicly available on the course website. In the live streams, use the public chat. In online data collection and management, I also highlighted to the use of Twitch. I just want to highlight this again to the new students. One way in which you can learn and collaborate with each other too is to start live streaming your activities when you meet with teams. Invite other students to comment on your work in chats. I've done this last year and it worked okay, but I don't know. Maybe this is something for you. So if you have some experience on this, why not? Help me as a moderator, maybe share screen with TeamViewer. All that information is on there and you can revert back to the ODCM introduction lecture for more details on this. The project is going to be based on public data from a website called Inside Airbnb. This is the website, and it essentially provides you with data on anything related to Airbnbs, and in Amsterdam or any other city, it is available. For example, for Amsterdam, you see what are the listings, and it's quite recent, right? What are, customer reviews, summary information, neighborhoods in which Airbnb is busy, and you have this for many cities around the world. So one thing that you could do is, well, get inspired on what are important questions for Airbnb to study. Think commercially, how did the COVID lockdowns affect, I don't know, Airbnb revenues, and compare that across cities and write a little app that uses this data and displays that stuff. That's one way. Or you can write a research on, whether, I don't know, Airbnb discriminates against visitors, more public policy perspective. I don't know what to do with this data, but this is the data that you're going to use for your project. You're going to build an entire research pipeline, exploring the data, preparing the data, analyzing the data, and importantly, unlocking the results in a good way. And we're going to use self and peer assessment. So later on, you're going to get a survey on like evaluating your own performance and the performance of your team members. Suppose you have that free rider, and that free rider gets like bad evaluations on quality and quantity of contributions. Your free rider is not going to get the same team grade as you get. You're going to get uplifted while your free riding colleague gets downgraded. So it's a little system that we use. In the tutorials, we make use of publicly available content that other people have developed too, right? So for example, we like to invite you to DataCamp. There's all instruction to get signed up to premium material on DataCamp. You have free licenses to do this, but you need to do it in the right way and get support by the library at Tilburg. Just check out our page. We get some info on this. And software carpentry, another open, well, this is actually an open site to follow. A really good site, I think. It looks a little geeky. So I hope Tilburg Science Hub looks more fresher, but you know, it's a good website, good content. It will require a lot of effort from your side and feedback from my side. So be in touch. You'll learn how to collaborate on GitHub, explore new data using our markdowns, prepare data sets for analysis, and automate your workflows. And all of these skills are highly valued by the job market. The online exam is going to weigh in heavily with 60%, while the team project weighs in with 40%. My commitment is I'll boost your efficiency, but you'll have to endure the pain of learning these things. Sorry for that, but let me be quite clear about this. You won't become an R expert, but you'll get the gist of it. We're going to discuss your own work and ideas as much as possible, but it requires you being in touch with me. Finally, bring in your own ideas, right? I mean, if you have ideas on how to do things differently, just be open and talk to me about it on WhatsApp, or you know, if you feel more comfortable sending an email, to make this course really your own, right? Because while I'm like running the show, in a sense, I'm very much open to your suggestions, and hope that eventually you'll be in charge of determining what happens here. I have a slide on coding advice, but I defer to the ODCM introduction lecture, I think, because both courses are mandatory in the analytics program. You'll have to rewatch this content anyways. Otherwise, read the slides on your own. If you want to get in touch with me, these are the steps, right? First, seek out the support of others publicly or in this class. I saw there was a link posted to an internal WhatsApp group, which I'm not joining, but you can, right? Ask your colleagues. If you don't find an answer, be in touch on WhatsApp. So this is the QR code, so please scan it and add me. I've already chatted to a couple of students, so it's a good way to interact. Sometimes I just call you, so don't be afraid, because, you know, before I write like an email and it takes me 30 minutes, I could just like call you, set up a session and answer something like really quick, right? So let's make this a little more modern than what you're used to. Like in online data collection and management, you'll learn essential job market skills, show off your expertise, because in this course, after you go through this, you may also be able to create own websites. For example, like the data scientist that developed this course for me, you know, it's a flashy looking way to enter the data science world and have a little portfolio of what you do. You know, this is also just another way of disclosing the results of your research. And you can use the tools and the GitHub stuff that I teach you to do this. And it's an exciting area. It opens up new business models and new methods and new technologies to you when you're a little open in improving coding, collaboration, and automation. I think that's kind of my pitch here. I apologize for being very quick on those technical parts, but realize that this is the content of the course. The course is just starting, and this is a little teaser on what to expect from this course. So right now, I'd like to open up the floor for comments, feedback, I don't know, suggestions, questions. So please use the chat or unmute yourself to let me know any remaining, let me solve any remaining doubts. By the way, I'm still looking for this video editor. So please show up if you can edit videos for me, because otherwise it will also take forever for me to edit the videos for you. Is there a reason we use R in this course and Python in the other? Yeah, so why is that? I got the same question in the other course. Why don't we use R for web scraping? Why do you use Python? So let me see. R is my standard way of running empirical analyses. Python is way bigger. R is way more focused on data analysis and data preparation. Number one. Number two, the working with large data sets in R is much faster than it is in Python. Python always loads all of the data into memory. So if you have like a large data set that doesn't fit in your memory, you'll run out of space and you can't do it. R is way more efficient in handling this. And I run all of my research projects, and most of my colleagues run all of their research projects in R. So R was the natural choice. R is also a standard language that you use in firms. So my wife, for example, she works for a book publishing company, and they do all of their analytics in R. You know, do you have to be married to R? No. You can switch to Python eventually if you think that's more useful. But my experience really is that R is just superior in handling analytics, while Python is better in handling machine learning. The other thing that this course does is it actually can also teach you to do both at the same time. You know, have your data being prepped in R, and then that final data product is being pumped to a Python script that does some fancy algorithm where there's only a Python package available. There's no, one size fits all solution. This is the course that stitches it all together, but we'll use R to do this. That's the answer on this one. Paulus, this course seems a lot harder. Yeah, I don't know. Maybe I didn't do a good job in selling it well. Students found the other course, ODCM, harder last year. So yeah, it depends. Why do you think it's harder? Maybe that's a good way to approach this. Oh, you're scared. Oh, come on. Yeah, but it's if you look at this, the first thing that you need to do is just copy. I mean, you can walk through this tutorial and be done in 30 minutes. I'll promise you. And you have your first app and running. So, I don't mean to scare you. I just want to show you that this is possible. And if you lose motivation throughout because you think, why am I doing this? Think about this app that you will be able to build at the end of this class. All right. Yeah, and Wouter, the relationships between this course and the other course, exactly. Online data collection management is the beginning of a research. Collect a data set and don't even think so closely about the exact research question. Think about an amazing research context that you want to study. Let's say influencers on TikTok, I don't know, right? This course is about taking this data, merging it with other data, wrangling with it to get the data set that you actually end up analyzing, running the analysis and reporting on the results. So exactly that's what you're saying. Yeah. So maybe another way to go back is I had this framework, maybe before this is like data collection, and then comes exploration, data preparation. This is what we do here, and data collection is online data collection and management. Just because we cover 4 things here doesn't mean it's more complicated either. All right, that was useful, I believe. Any other things that you want to ask? The code is scary for someone who never coded. Yes, it is. I'm trying to take away that pain. So the first tutorial that you're going to work on is, let me see, what is it? Our bootcamp. So I'll show it to you real quick. It's this one. It actually starts how to find your way around RStudio. Let's start with this lesson, right? Why learn R? It gives you the explanation. Sorry, I didn't record this, but it's way more efficient, to use something like this. It compares R to like other programs, and I don't know, getting set up. It shows you where to write code. It starts at the very, very beginning of history, I would almost say. It's designed to participants with no programming experience, all right? It's copy pasting, but also building an understanding about what goes on, all right? And what we'll do in these live streams is that I'll do parts of these tutorials too, to ask a question, and you'll learn more things. Actually, you can't imagine how useful it is to just see somebody code. And that's what we're going to do in the live streams next to some other activities, all right? So how I think you need to get started is, what's the week kickoff, which I haven't recorded yet. Sorry for that. So let me see. You go to modules. If you haven't done the prep, do the prep, especially get your DataCamp premium account working, because you're eventually going to need it soon, okay? Explore Tilburg Science and do that prep week, and then zoom in on week 1, complete the software installation, work on the bootcamp. If you know R, you know, you have a chill week. If you don't know R, find peers, you know, find that one person that you can relate to that knows just a little bit more than you. That's sometimes enough to, like, you know, help you make progress on learning it. And remember that I don't want to let you drown in too much material, or I actually want to prevent, by all means, that you're stuck on a little problem that takes me 1 second to solve. So please make active use of the WhatsApp support in this class to help you, you know, move ahead. Share whatever I tell you with others, so I don't have to repeat myself all the time, right? But let's try to define on how we want education to be online, right? And then finally, this course is just like ODCM online because it always was developed to be online. So, and I think it just works best like this. All right, any other things that you would like to discuss? Good, then I'll close the recording for now. Thanks a bunch, but I'll stick around for any other issues that you don't want to talk in public. All right, thanks a bunch.